Hi, Kim Rimby here with KP Mathematics, and today I have a question for you. What would you think if I told you that the number sense gap that you're experiencing with your students is not isolated to your grade level? In fact, it's a gap that runs across all the elementary grade levels. Would you believe me? Today, we're going to focus on one part of number sense, and that's the idea of place value. Far too often, our children develop a fragmented, very shallow understanding of what place value is because they just learn about ones, tens, hundreds, but they don't really have a gut feeling for the magnitude of numbers, both very small and very large. So let's play a game. I want you to guess, how long would it take for 1 million seconds to pass? And don't say 1 million seconds. I'm talking how many days or weeks or months or years would it take for 1 million seconds to pass? Did you make your guess? Here we go. It takes 11 and a half days for 1 million seconds to pass. Kind of a long time, right? So, given that information, how long do you think it will take for 1 billion seconds to pass? In days, weeks, months, years, how long would it take? It takes 11 and a half days for 1 million seconds to pass. Do you have your guess? How long did it take for 1 million seconds to pass? 11 and a half days. But 1 billion seconds takes almost 32 years. That's a pretty big difference when you go from a million to a billion, yeah? So, next guess, given that information, how long will it take for 1 trillion seconds to pass? Got your guess? Well, it took almost 32 years for 1 billion seconds to pass. It's going to take almost 32,000 years for 1 trillion seconds to pass. So let's go back again. Back when we were talking about 1 million seconds, that took 11 and a half days. 1 billion seconds takes almost 32 years. 1 trillion seconds takes almost 32,000 years. Was your number sense just bumped up a bit? Does that shed some light on the national debt and the national deficit? Often we as adults think of millions, billions, and trillions. We just think of really big numbers, but we don't necessarily understand the magnitude as we change from each one of those periods to the next. The same thing is true with our students. Although with our youngest students, it's understanding what's the difference between 1, 10, and 100, or 10, 100, and 1,000. We bump into fourth grade and we're working up to numbers within a million. And in fifth grade, we're working into trillions and beyond. So that happens really fast. We spend 4 years working with numbers within 10, then with numbers within 100 in first and second grade, numbers within 1,000 from second to third grade, and then all bets are off. So, how can we do this? How can we help our students really grapple with a gut feeling of these numbers? One thing that I have found to be really important is helping them understand and experience grouping principles. For example, if you hold a card like this up and you ask students, how many dots do you see? Take a guess. What do you think they'd say? What would be your guess? Right? Usually, when I do this with a group of adults, I'll get guesses anywhere between 30 and 80. And so, what I'm going to show you next is, can you tell me now how many dots are there? Same number of dots. And now you can see there's 53, right? 5 groups of 10 and 3 extra 1s. But when you ask a child, a 5, 6, 7, 8-year-old, to envision the number 53, this is what they see in their mind's eye. They don't think in grouping structures, they think in individual things because they are not thinking in groups yet. And this is the goal. This is what our number system is based on. And our students need many, many experiences to be able to get there, for in their mind's eye, for them to see what's happening with the grouping structure. And that's why it's so important to be using some kind of manipulative, some kind of visual that helps them see those groups. Of course, my favorite tool right here is KP 10 frame tiles because kids can simply put these tiles on here, right? and make a group of 10. And then it becomes one group of 10, still 10 ones, but one group of 10. And we continue building and building with that particular model. You can use base 10 blocks, right? This is the tool that most of us have been familiar with for most of our careers, right? Where you have 10 ones, 10 units, and we trade it for one rod, or 10 rods that we trade for one flat. The problem is that that trading doesn't quite reflect what's happening in the number system. We want to be able to nest. And so that's the type of tool I like to use. But let's go back for a second to, okay, we want our kids to start thinking in groups of how do we know where they're at? Here's one suggestion. Give them a number like 17 and say, okay, here we have the number 17. I want you to put this much in my hand. And we're going to see, do they put one in your hand, or do they put one group of 10 in your hand? And that's the goal, is we want them to see that that one right there, although it's a one in the tens place. It has a magnitude of 10, and we want to make sure that they understand that that's one group of 10, not just one single item. So that's one way to see, are they starting to unitize? Are they starting to think of 10 ones as one group of 10? We also are going to need to get into bigger numbers. And so if we have the number 256, we're going to want to do all kinds of grouping and moving around so the kids can see what that looks like. But then once we get into these larger numbers, I want to be able to point to the 6 and say, okay, this is the number 256. How much is one more? Hopefully they say 257. Okay, how much is 10 more? And we're looking for 266, right? How much is 100 more? We're looking for 356. Can our students tell us what's happening in each digit as that magnitude shifts? Because of course this is a 5, but it's in the tens place, which means it has a magnitude of times 10, which makes it 50. That's the kind of understanding we're looking for with our students. So whether you're working with 5-year-olds or 10-year-olds or 12-year-olds, whatever grade level you're working with, this kind of understanding is pivotal. And I promise you, a lot of your students have learned how to rotely talk about the places and the values, but they haven't internalized that really great, deep understanding of what's going on with small numbers and very large numbers. Number sense is understanding the magnitude of what's going on with a set of numbers. And so that's what I challenge you to do today. I hope this was helpful. Please try some of this out, see how it goes for you, and I'll look forward to seeing you next time.